So here's a question you see all the time online. Are our human CO2 emissions really that big of a deal compared to, the massive power of a volcano? It's a totally fair question, but it's one that really needs a solid data-driven answer. So let's jump in and actually look at the numbers and separate geological fact from some common fiction.
Here's how we're going to tackle this. First, we'll look at the big picture, the planet's natural carbon cycle. Then, we'll put on our detective hats to see how scientists even measure an invisible gas. After that, we'll piece together the new global tally, deliver the final verdict, and then talk about why all this research really truly matters.
All right, before we can even start comparing numbers, we have to get some context. See, volcanoes are a crucial part of this absolutely massive planetary-scale system that's been running for millions and millions of years. And that system is called the geological carbon cycle. You can think of it like the Earth's deep, slow breathing. CO2 comes out from the planet's interior, mostly through volcanic activity, and then it's pulled back in through things like the weathering of rocks. It's this incredible, self-regulating loop that has kept our planet's climate pretty stable for eons.
Now, the key thing to get here is that this is a balanced system. Volcanic CO2 isn't some kind of disruption. It's a fundamental part of the process. Gas comes out, it joins the atmosphere and the oceans, and then eventually it gets drawn back in, closing the loop. It's a natural rhythm the planet has been in forever.
Okay, so understanding that system is one thing, but actually measuring how much CO2 is coming out of it, well, that turns out to be a monumental challenge. And hey, don't just take my word for it. This quote from 1989 just says it all. Scientists called counting this CO2 flux the most vexing problem in understanding the whole carbon cycle. And think about why. You're trying to hear this tiny whisper from a volcano in a room that's already filled with the shout of background CO2 in the atmosphere. It's incredibly difficult. So how in the world do they do it? How do you measure an invisible gas coming out of a volcano when that exact same gas is literally all around you already? Well, it takes a global effort using some seriously clever techniques. Scientists might measure the ratio of CO2 to another gas that's easier to spot, like sulfur dioxide. Or they'll use these special chambers to trap gas that's just seeping out of the soil. They'll even fly planes packed with sensors right through volcanic plumes, or send tiny submarines down to sample vents on the deep ocean floor. It's some real-life scientific detective work.
And thanks to all of that hard work, we now have a much, much clearer picture. So let's get to the new global tally and see how all these different pieces of the puzzle add up.
All right, first piece, the gas that's coming right out of the plumes of about 150 volcanoes that are pretty much always active. These are the classic ones we all picture. This adds up to an estimated 271 million tons of CO2 per year. Okay, let's lock that number in our heads. But wait, there's more. Volcanoes also kind of breathe through their skin. It's called diffuse degassing. It's just invisible CO2 seeping out of the ground across their huge surfaces. And this quiet, invisible process, it adds another 117 million tons per year to our total. Next up, we've got a source that honestly was mostly overlooked in the global numbers until pretty recently: volcanic lakes. It turns out the world's 700+ volcanic lakes are quietly releasing a ton of CO2, adding another 94 million tons a year to the pile. And the list keeps going. We also have to account for emissions from bigger geological features, things like fault lines and geothermal systems. This kicks in at least another 66 million tons per year. So let's add all that up. You've got the plumes, the gas from the soil, the lakes, the tectonic areas. All the on-land or subaerial sources give us a grand total of about 540 million tons of CO2 per year. Now we're ready for the big comparison. Okay, we've carefully built up our total for all the geological sources. Now it's time for the main event, a direct, head-to-head, data-driven comparison.
So let's bring it all together. We just need to add one last piece to our volcanic total: the emissions from volcanoes that are underwater at mid-ocean ridges. Once we have that number, we can finally put it right next to human emissions and see how they stack up.
And here it is. The total global volcanic output, once you add in those mid-ocean ridges, is about 637 million tons per year. Now, just look at that other bar. Annual human-caused CO2 emissions, that's 35,000 million tons. That's not just a little bigger, it means our activity every single year emits over 50 times more CO2 than every single volcano on the planet combined.
So the verdict is pretty clear, right?
But this research gives us so much more than just a number. It gives us a crucial understanding of scale and of how our planet actually works.
And this research reveals something really surprising, something almost counterintuitive. We tend to think of these huge eruptions like Mount Pinatubo in 1991 as the main event. And yeah, it released a mind-boggling 50 million tons of CO2. But that amount is actually less than what all those on-land volcanoes quietly breathe out every single month. The real story here isn't the big, flashy explosion. It's the slow, steady, continuous release of gas.
And you know, that brings us right back to where we started. That deep, slow, planetary breathing. The big takeaway here isn't that volcanoes are weak or insignificant. Far from it. They are a powerful, vital part of a balanced system that has kept our climate in check for ages. The real takeaway is that our human activity has become a new force of nature, one that is now completely dwarfing that ancient, natural process. And that, well, that really puts the scale of our own impact into a whole new perspective.